Good morning, students. We'll be learning regarding the evaluation of Postpic expression under the laboratory program 5 in data structure with C laboratory. So 5A, we need to learn regarding the evaluation of Postpic expression, that is program 5A, and 5B, we'll be solving the Tower of Ani. So we had already discussed regarding the application of this stack in the program 4. In the program 4, we had seen regarding the conversion from one form to the other. In this program, second application will be seeing, that is regarding the evaluation. Here we are seeing regarding the evaluation of Postpic expression, and the third application is nothing but the recursion. In the recursion 5B program is there, that is regarding solving Tower of Ani problem. So before we go to the program, let us see what is a Postpic expression. Postpic expression. A Postpic expression is a collection of operators, and operand in which the operator is placed after the operands. So a Postpic expression is nothing but it is a collection of operators as well as the operand. So as you know what is operators. Operands also is alphanumeric. Here operands, while you're solving the evaluation of a Postpic expression, obviously the operand should be an integer. So over here, operand 1 and operand 2, for example 1, 2, it should be followed by an operator. So this is a valid Postpic expression. So 1, 2 followed by an operator. After that, this is a complex example just given over here, that is 5, 4 plus 6, 5 minus division. How to solve this we'll see in the algorithm of the Postpic evaluation of the Postpic expression. So a Postpic expression is nothing but a collection of operators and operands in which operator is placed after the operands. For example, it may be like this also, 4, 5, 6 plus, okay, 4, 5, 6 plus minus. So that means in a Postpic expression, the operator follows the operands. The operator always follows the operands. So this is regarding the definition of the Postpic expression, and these are the two examples. Okay, now let us see the algorithm of the evaluation of Postpic expression. So the process of how algorithm works, I'll tell while solving the problem, but let us see what things we are going to do over here. What all things you need to do while doing the evaluation of the Postpic expression. One, you need a stack to store the operands. So don't get confused. Operators is plus minus, operand is like an integer. So create a stack to store an operand. So you need a stack where you can store the operands. For example, like 2, I'll just give a simple example over here. Let us solve this. 2, 5, 6. Okay, 2, 5, 6 plus and star. Let us take this particular example and solve this over here. So I'll write symbol here over here, 2, 5, 6 plus and minus, and this is the stack, this is the symbol, and whatever the operation you're going to do, operation is like push or pop you're going to do, that I'll write over here. So create a stack to store the operands, so whenever you find an operand, you're pushing that into the stack. Okay, that is regarding the create a stack to store operands. So here we found 2. So we are directly pushing onto the stack 2. Then we found 5, 2, 5. Now top stack is 5. Then you found 6. You did 2, 5, 6. All the operation you did is what? Push. Okay. So create a stack to store the operand. Scan the given expression and do the following for every scanned element. If the element is a number, yes, it is a number. Push into the stack. I pushed over here. Pushed into the stack, and operation what I did is push. If the element is an operator, now my element is an operator. If an element is an operator, what you're supposed to do is pop 2 operands from the stack. See from here, which will be popped first? 6 will be popped first, right, as it is. Next, this is the 2 pops. 2 operands you have to pop. Then it is 5 will be popped. So if the element is an operator, pop 2 operands from the stack. I pop 2 operands from the stack, and whatever this operator is there, I'll place in between them and do the evaluation. So what is 5 plus 6? It is nothing but 11. So I did that, and it should be written in this way itself, because in case if subtraction comes, right, whatever the stack top you write here, next right here in between you place the operator. Meaning is what, this is op 2, this is op, when you pop, right, this is op 2 and this is op 1, that is operator operand 2 and operand 1, and this is the operator. So 5 plus 6 is 11. You got the answer as 11. That answer needs to be pushed back to the stack. In your stack you just add 2 because you popped these, right? You popped 5, 6 and you wrote over here. You popped this, you evaluated with this plus operator, and you got the answer as 11. Once you got that answer, you push that particular answer into the stack. Here you need to write pop 2 operands and evaluate, pop 2 operands and evaluate. So 2, 11. Now what is happening? Here it is minus. So again next is operator itself. So when you have operator, again pop 2 elements as it is. So 11 and 2, you write it in this way. 11 first, 2 place minus over here. So you'll see, this is how you cannot write 11 2. If you write 11 2, answer will be different. So 11 over here, whatever the stack top is operand 2 and operand 1, minus is over here. So 11 minus 2 minus 11 is what? Minus 9. So here you got minus 9. Here also you should write pop 2 operands. So if the element is an operand, pop 2 operands from the stack, evaluate the operator and push the result back to the stack. This is what is the meaning. So minus 9 I pushed back. When the expression is ended, the number in the stack is the final answer. Our expression is ended. The number in the stack. So result is minus 9. So this is regarding the example 1 I've written over here. Other one is example 2. So let us solve these two set of problems. So symbols I've written over here: 4, 3, 2, 5, star, minus, plus. So I've written all the symbols over here. What is the algorithm? If we find an operand, we are directly pushing onto this stack, and then we are writing the operation as push. When we find an operator, we are popping 2 operands from the stack and performing the operation, that is evaluation between those with this particular operator. So let us solve this particular problem. So here symbol is 4, so we are directly pushing onto the stack. Operation is push. Again 3, then it is 4, 3. Operation is again push. 2, again we are pushing 4, 3, 2. As it is, whatever is there, we are keeping as it is. New element we are pushing 4, 3, 2. Then again 4, 3, 2, 5. This also is push operation. Now we found multiplication. When we find multiplication, we are pop 2 operands and evaluate. Pop 2 operands and evaluate with operator. Okay, with operator. So here, what are the 2 operands we are popping? We need to pop 5 and 2. What is the operator over there? It is multiplication. So that answer I'm going to push over here. So 5 2 it's 10. So 4 and 3 as it is, I popped these 2. So 5 into 2 is 10. I'm writing over here. Same thing when it comes to minus. What we have to do? We have to pop this. So I'll not write the statement. You just write the statement over there. So it is 3 and 10. I'm write as it is. Then I'm placing a minus. 3 and 10. Pop 2. Same statements you write. Okay. Pop 2 operands and evaluate with the operand. Then 3 minus 10. It is nothing but 4, minus 7. Next again it is an operator. So pop these 2 elements. That is, as it is you write minus 7 and 4. In between you put plus. So it is 4 plus minus 7. So the answer is minus 3. So this is the result. This is the result for the evaluation of this particular postfix expression. So I'll just repeat. Whenever you find an operand, you just push onto the stack. Whenever you find an operator, pop 2 operands from the stack and place an operator in between these as it is, how it is there, write it like this itself, 2 comma 5. Why? Because in case if you write 5 comma 2 and when you do subtraction, for example you wrote 5 and 2 and you had subtraction, answer is 3. But if it was 2 and actually it was 2 and 5, and when you do 2 and minus 2 minus 5, answer is minus 3. So answer varies. So that's why you need to pop these two elements, right? I write as it is. First is popped this, next it is popped this. In between them, for example 5 and 2, in between them whatever is there, that you are placing. Here 3, 10 is here, 3 is here, then minus. So 10 minus 3 and 3 minus 3, answer differs, right? That's why you need to pop exactly here and then evaluate with the operator. So again same way it continued with all the operator. This is the answer. Now for example, if you had minus 3 and then you had something like star, okay, again star. Imagine you had just a star over here and here it is minus 3. So over here what we do, actually pop two operands and do this operation. Since we don't have two operands over here, whatever is there in stack top, right, that will be an answer. But it is not a valid infix expression. When you give this star, extra star, it is not a valid infix expression because we should have two elements to do this particular operation. That's why in case if you give, then it's an invalid postfix expression, and it will just display that what is there in the top. For example, now till your answer is minus 3 correct. When you give this multiplication, when you give a postfix, in case if in our program it will give invalid, but in case if you give this, whatever is there in the stack top, right, that will be displaying. So while give a valid postfix expression. So this is regarding the example 1. Example 2 is, here we have written 5, 3, 7. All these symbols have written over here, that is operands and operators have written here. Let us start with the program. So here this will be 5, push, operation is push, then 3, 5 comma 3, again operation is push, then you have 7, 5 comma 3 comma 7, again the operation is push, then you have plus, so it is between 3 and 7, so it is 5 comma 10. So what I did, pop two operands, and evaluate, okay, pop two operands and evaluate. So it is 7, 3, and then I put a plus, so answer is 10. Then this 10 result should be pushed back to the stack. Then that 10 result should be pushed back to the stack. Here, again it is pop two operands and evaluate, and push the result back. Okay, now what is this? 10 as it is, 5 as it is, star in between, answer is 50. So that 50 should be pushed over here. So this is regarding till here. After that you have 2. So 2 means what? 50 comma 2, that is push. And then you have 50 comma 2 comma 8, again push. Then you have 50 comma 2 comma 8 comma 4, 50 comma 2 comma 8 comma 4, again push. Then you have division. When it division, you need to pop this, pop two operands and evaluate, okay. So it is nothing but 8, 4, division in between. So 4 ones are 4 twos, answer is 2. So 50 comma 2. Next is plus. When it is plus, again pop these two operands. So same thing, I'll write pop two operands and evaluate, but here it is 2 plus, so it is 4. So it is 50 comma 4. Okay, and here also it is pop two operands and evaluate, that is 50 you will write here, 4 you will write here, multiplication. Answer is 200. Okay, answer is 200. Here it is continuation is over here. In stack top you have 200, you got a 6, so again push, get 200, you got a 6, again push. Next you have modulus, so pop these two I'll not write, I'll just write pop 2 operands and evaluate. That mod 6 and 200 is over here, and modulus. So what is 200 modulus 6? Remainder is actually 2. When you modulus of 200 modulus 6 is, because 6 goes 33 times the 198. Okay, that is 6 into 33 is 198. So remainder is 2. So 200 modulus 6 result, you will get it as 2. Whatever that result is there, that will be pushed over here, 2. Now here again 2 has to be pushed, that is this 2 and this 2, so it is push. Then you have power symbol. So what is power symbol? As it is, right? First this 2 over here, this 2 over here, in between power. So 2 power 2 is what? Nothing but answer is 4. So final result is 4. So this is a complex problem which involves all the operators, So this is regarding the example 1, example 2, as well as regarding the algorithm. Laboratory program 5. Now we'll see the lab program 5. So lab program 5 is regarding design, develop and implement a program in C for the following stack applications. The first one, as I told, it is nothing but the evaluation of postpic expression with single digit operands. It's not a double digit, it is the single digit operands and operators. So the operators are, all these are the operators we have to do and solve. And next is solving tower of one-eye problem with n-disk. So in this session, that is laboratory program 5, first session we'll be learning regarding the evaluation of postpics, and the second session let us see regarding the solving tower of one-eye program with n-disk. So let us see the program. So here are the header files and the global declaration as well as the function declarations. So ash includes standard io.h, already you know regarding it. We are using for the printf and scanf, and math.h is for math functions. In this program we have involved a math function called power. So we are using ash include math.h for using the power that is 2 power 2 you want to find, right? So I'm using a power over there, so that's why I'm using ash include math.h. And then while we solve the problem, we had to push and pop. Whenever we found an operand, we did the push, so we need a push function, and whenever we found an operator, we popped 2 operands and then we did the evaluation. So for that we need these 2 functions, that is void push and pop. The function is same what we have seen from stack, as well as it is same regarding void push. And then we need to evaluate a postpic expression. For that we are using this function, that is nothing but void evaluate. And initially stack, we are declaring size stack array size 20, and initially top is equal to -1. If stack does not contain any elements, then top is equal to -1. So let us see the push and pop operation. It is same what we are seeing in the 4th program. So I'll just discuss regarding here. So here whatever the item is there, that is declared as float, like whatever the item. For example, if you want to find now for example you had 1, 2 and division, okay, 1, 2 and division. So what will happen, it is answer is nothing but half, so that is again a floating point, right? 0.500. That's why I have declared all the items as float, all the items as float over here. So void push float item, in case now I want to push 2 and 5, what will I do? Stack. Now for example I'll just show an example over here. 2, 5, what will I do over here? Push. This is my expression of postpic expression. So 2, 5, plus. So if it is a push, what we have to do, if we find this 2, 5, we are doing 2 over here, that is nothing but push. So what we actually do, that is nothing but top, initially top was -1, top will be incremented, top plus 1, and then stack of top will be what now? 0. In that 0 you're pushing the item as 2, so here 2 came. Next again iteration 5 is there. What it will happen again, top should be incremented, that is meaning of this is what? Stack top plus 1. So meaning of this is stack top plus 1. What is there in top now? Top was initialized to, now top was 0, so top is equal to top plus 1, increment top plus 1. So stack of 1, first it will increment, then stack of 1 will be having 5. So here it is 2 comma 5. So this is regarding the push operations. So when the pop function comes, this is regarding push. First you increment the top, then stack of top. Now top is equal to top plus 1, then stack of top, you're placing an element. So same thing happens over here. Next, when it is pop, what you are going to do actually, return stack. Now you had when it comes pops, what we have to do, this we should pop and this also we should pop, and then we should do the evaluation, right? So how will it pop this? When I do the pop, I'm just returning the stack top. What is that stack top now? Top is what? 1. So I'm just returning what is there in stack top, that is 5. What is there in stack top? 5. Then I'm decrementing top is equal to top minus 1. So the value is, for next iteration, the value of top is 0. So 5 is already been returned over here. So then now next here top is pointing over here. Now next again return stack, I need to pop 2 operands, right? So return stack top minus 1. So again stack, what is there in stack top needs to be returned. So that is nothing but 2 will be returned, and then for the next iteration top will be minus 1. So this is how the pop works and the push works. So this is regarding push and pop operation of the stack while doing the evaluation of the postfix expression. So this is the function to evaluate the postpic expression with single digit operands and operators. So over here I've already taken a postpic expression. I've already written a postpic expression which we have solved in the example problem. So I've written over here 537 followed by these operators and operands. So this is our postpic expression. So let us try to trace this particular problem. Over here we have taken operand as floating point as well as the result over here. So float operand 1, operand 2, and the final results where we want to store. For example, operand 2 we popped this way and operand 1 and in between them, and finally the result also need to be stored. So that we have taken it as a floating. And a symbol to store each operand or operator, I need a character symbol. So over here for I initially, for I equal to 0, for I equal to 0, postfix of I, this is my postfix expression. What is there in postfix of I? For I is equal to 0, we have postfix of 0 as phi not equal to null character. Phi not equal to null character. Whether it is equal to null character, no, it is until the end of the string you have to do this. It is not equal to null character, so it is true. If it is true, whatever is there in the postfix of 0, that is phi, need to be stored in sim. So your sim will be having now phi. Okay, if is digit sim, if your sim is a digit, yes, if is digit sim is a phi, check for digit or not. Yes, it is a digit. If it is so, push sim minus 0, push sim minus 0. Now what is happening over here, since your sim is in character, so we need to push that particular sim into stack. Okay, since it is in character, we need to convert in the ASCII format. So what is the ASCII format over here? Sim is your phi. So this phi minus is 0. So I'll write over here. If is digit sim is true, if is digit sim is your phi, so push ASCII value of phi minus 0. So the ASCII value of 0, you know, 48. So phi, this will be 53. So 53 minus 48 is, again you'll get it as phi itself. Why we are converting over here is, since it is declared, sim is declared in the cat, we need to form the we need to convert to the ASCII to the number conversion. Since it is in character, we need to convert to the number conversion. So ASCII value of sim is nothing but phi, it is 53 and 0 is 48. Back to that we have to convert into number conversion, so it is phi. So this phi needs to be pushed. You know, whenever you find operand, you're pushing directly to the stack. So sim is equal to postfix. Yes, you compared over here whether it is a digit. Yes, you got a digit and you're directly pushing that into the stack. Okay, push sim minus 0, that is nothing but ASCII value of this minus ASCII value of 0. So that will be 53 minus 48. You will get directly the answer as phi itself again. So that you are going to push into the stack. So let me, this is a postpic, right? So let me write yours. Let me write the stack over here. Let me write phi. That is stack. Also we are declared 20. If you remember, float we have declared initially in the header files. While I'll declare the stack. So this is the stack, this is the postfix. So 0, you will be holding the element as 5. So this is regarding the first when I read. And then switch sim we have. Switch sim is nothing but here instead of sim you have 5. For that 5, check any cases are there. No, whatever the switch case is there, right, that is only for the operators. If you see, it is only for the operators. So it will come out of this switch. So it will come out of this switch. So it's already been pushed. It will come out of this switch. I will be incremented now. Now your I iteration is 1. So I iteration is 1. So next when it is 1, you will check whether 3 not equal to 0. 3 not equal to null character. Yes, it is not equal. So it is true. Now your sim will be having 3. Now your sim will be having 3. Okay, now your sim will be having 3. You will check whether if is digit sim 3. Yes, it is a digit. If it is so, push ASCII. I mean, you need to convert to a number conversion. That is ASCII value of character 3 minus 0. So it is actually when it is 5, it is 53, right? When it is 3, it is 51. It is 52. 52. So it will be nothing but 52 minus, it is actually 51 minus 48. So it is, sorry, I will write again over here. So it is ASCII value of push 3 minus 0. So it is nothing but ASCII value is what? 52. It is 53 for 5. So it is 3. It will be 2 less. So it will be nothing but 51 minus 48. So it is again, you will get the value as 3. So this you need to push, right? So whatever the conversion you did is number. So you push into the stack. So again, switch 3. Obviously, we don't have any operand in the switch cases. So this will not work. So it will come back over here and it will increment the I value. So I will be 2. When I is equal to 2, you will check what is there into. It is again 7 not equal to null character. So it is true. So again, sim is equal to 7. Sim will be 7 over here. Sim will be 7 over here. Whether it is a digit, yes, it is a digit. If it is a digit, push ASCII value of 7 minus 0. So you will get again 7 itself. Answer will get it as 7 itself. So that 7 will be pushed over here. So done with 537 over here. 537. Now I value again will be incremented because 7 again will not go into the switch statement. So I value will get incremented. Now I will be 3. When I is equal to 3, you will check what is that. Plus is not equal to null character. Yes, it is true. Plus is not equal to null character. It is true. If it is true, it will go to this sim is equal to, now your sim will be having plus, it will check if is digit sim, if is digit plus. No, it is not at all a digit. Okay, so it will not come to this particular function. It will directly go to switch plus. So when it goes to plus, check over here. When it goes to plus, when we have an operator, what we have to do? We need to pop 2 elements from the stack. So these 2 pop, I'll do here itself. 7 and 3 needs to be popped. Our job is nothing but, I'll write here. 7 and 3 needs to be popped, and this needs to be put in between, and then this is the 10, and this needs to be pushed back to this stack. Okay, so when you find this plus, you pop 2 operands, put an operator, do the performance of the evaluation, push back to the result. So come back over here. Op2 is been popped. What is op2? 7 is been popped. Okay, 7 is been popped. Op1 is also popped. Now what will be the result? Here it is 7 and here it is 3. So 7 plus 3 is nothing but result will be 10. So this results needs to be pushed back into the stack, So here anymore it will be not 37, it will be updated to 10. So this is the stack 0 1. So this is for the iteration. So done with that iteration, push the result. I have pushed break, it came out of the switch statement, and I got incremented for the next iteration. So I is equal to 4. When I is equal to 4, you have multiplication your multiplication, so you'll check whether multiplication is not equal to null. Yes, it is true, it is not equal to null character. Then sim will be having multiplication, and you'll check whether if is digit sim, it is not, so it will not come over here in the switch directly, it will come to the switch. So switch is multiplication, so multiplication is over here. So when it is multiplication, op2 will be popped. What is op2 now? It is 10. Your stack top operand 2 is 10 and here it is 5. So you'll write operand 2 as 10 and 5. In between you'll paste a star. Result is 50 and this result needs to be pushed back to the stack. So this will be popped. Op2 is popped. This will be popped. Op1 will be popped. This will be popped. Finally you do the performance. Push the result back to the stack. Now your stack will be having just one value, that is nothing but 50. So your stack will be having one value, that is nothing but 50 is 0. Now your stack is having 50. Now again it came out of the switch statement. I got incremented. Now I is equal to 5. I is equal to 5. When I is equal to 5, what is this? It is 2. Obviously 2 is not equal to null character. So 2 is not equal to null character. Sim will be having 2. If is digit 2, yes, it is true. If is digit 2, you're checking it's true. If is digit 2 is 2, it is true. If it is so, push ASCII value of 2 minus ASCII value of 0. So that is actually when you see 48, and this will be, I think it is for 3 it is 51, so this is 50, so you'll get back the value as 2 itself. So push that into the push sim minus this. Since it is in character, I need to convert into a number. I'm using the ASCII conversion, so again I'm writing this as 2. I push it over onto the stack. Then switch 2 is not possible because in the switch case we have all the operators, so it will not go into the switch, it will fail with the switch, and again I will be getting incremented. So I will be 6 now. When I is equal to 6, check what is there. We have 8, so we'll check 8 not equal to null character. Yes, now sim will be with 8, sim will be 8, here sim will be 8. Now if is digit sim 8, yes, true. If so, push sim minus 0, so again you will get it as 8 itself. That is sim means ASCII value of 8 minus the value of 0, so it will be 8 itself. So here we'll be pushing 8 onto the stack. So push, right? Push is nothing but pushing operand onto the stack. So I pushed 8. After that you have 4, so I is equal to 7. You had 4, that is not equal to null character. That is not equal to null character. It is true. Now sim will be having 4. Sim is equal to 4. If is digit 4, yes, true. Then again, as if it is 4, push that particular element onto the stack. So it is 4 itself. 4 over here. Okay, so it is 0, 1, 2, 3. So 4. Till here we have pushed. Now next when I read, it is division. Okay, so next when I iteration, now I pushed over here, I will get incremented, so I'll just write over here. Now iteration is, okay, I'll write over here. I is equal to 8. I is equal to 8. When I is equal to 8, it is division not equal to null character. Null character. So it is true. Division not equal to null character. It is true. Now your sim will be, your sim will be having division. Okay, if it is division, it will not go to this. If is digit sim will not work, it will come directly to the, so this will not work, it will come directly over here. Switch this as sim as division. When it is division, what will happen? Same performance, right? When it is division also, you will pop, instead of multiplication you will be having division, you have to perform the division. So that function is defined over here. So what is there in the stack top, I'll just note down 8 and 4, 8 and 4. So it will come over here. In the stack top you have, in the stack I think you have 50, 20, 50, 20, I think it is 52, 8, 4. It's not 20, 52. This is your stack, 52, 8, 4. This is our stack. Okay, this is our stack, 5284. So over here, 5284. So over here, when we get a division, what we'll do actually, we'll pop these 4 and 8, and then we'll place this, and that is equal to nothing, you'll get it as 2, and then again we'll push back to this particular into the stack. Now when it is over here, op2 I popped op2, that is 4 I popped, op1 I popped, I'll wrote like this 8 and 4. Okay, I popped. If op2 is equal to 0, that is this if is equal to 0, in our case it is not equal to 0. In case if it is 0, what it would be? 8 by 0, infinity result, right? So that is not possible. So for that you write division by 0, error. If op2 is equal to 0, you'll do this particular. Else what we have to do? Result directly 8 by 4, that is nothing but answer is 2, and that results needs to be pushed back to the stack. I'll repeat again. Here in the case division case, op2 you'll pop, op1 you'll pop. In case if this was 0, then it would result in infinity, and it is an error statement. So division by 0 error, it's not possible for us. So for that I have written if condition over here. Else result is equal to op1 by op2. If not this, result is equal to op1 by op2, that is nothing but 8 divided by 4, that is equal to 2. So that result I need to push back to the stack. So here 8 and 4 will be popped, and the operation of division will be done, and then the result will be nothing but what we got was division. You know what result you got? You got it as 2. You got it as 2. That is, you can see here. So we got 8 division by 4 as 2. So the answer is 50, 2, 2. Now again operation is done. Now again I will be incremented. So I value is 9 now. I value is 9. 1 second. Now I value is 9. When I is equal to 9, what is there in the I is equal to 9? Plus. You'll check for plus is plus not equal to null character. Plus not equal to null character. So it is true. Now your sim will be having plus. So if your sim is having plus, it will not go to the if is digit, because plus symbol is not a digit. It will directly go to the switch of plus. When it goes to the plus, what will happen? When it goes to the plus, you know, this is the job. When it goes to the job plus, it will pop 2 and 2. So here operand 2 will be having 2, and here will be 2, and here it is 2, and here also it is 2. Now 2 plus 2 is nothing but 4, and that result needs to be pushed back to the stack. So here 2 will not be there. Instead it will be just 4. We had 2 over here. We took 2 out and placed an operand. Result is 4. That result I have pushed back over here, stack. So that is regarding the 9th iteration. Next I will be incremented. I will be 10, and you'll check whether star is not equal to null character. So it is true. It is not. Now your sim will be having star. So when it is star, again it is same. 4 and 50 will be popped, and that star, and the result will be 200. That needs to be pushed. So here you just check. In this iteration it is op2 is 4, and here it is 50, and result is 50 star 4. The result is nothing but 200, and that 200 needs to be pushed onto the stack. So I'll just erase this stack contained. So the result is just 200. That needs to be pushed. So your stack now contains 200. Okay, stack now contains 200. So that is 10th iteration. Next I is equal to 11. In the 11th iteration I have a digit, that is 6. Yes, 6 is not equal to null character. It is true. If it is true, then sim will be having 6. You know, when sim is equal to 6, if is digit 6, you will compare. If it is a sim, it is true. If it is true, push that particular 6 over here. Push that ASCII value. That is, as after ASCII conversion, I am pushing the 6 over here. And switch sim is not possible since it is an operand. So switch statement doesn't work. I gets incremented. So I will be now 12. In the 12th iteration I have a modulus. That is not equal to again null character. So it is true. Now your sim will be having modulus. In the stack you have 206. Your sim is modulus. So it will not go to this particular function. It will directly go to the switch. So it will come over here. So in your stack, what elements you had? It is 206. Okay, fine. In the stack you had 206. This was my stack. 0 and 1. So when it comes modulus, again operand 2 is been popped, that is 6, and this is 200. Same thing, if operand 2 is equal to 0, we cannot perform modulus, so it is again an error. Else what we have to do is, since we have to do we cannot do modulus for the floating point, we are typecasting it to integer, that is operand 2 we are typecasting to integer, and operand 1 also we are typecasting to integer, and then we are performing the modulus. So you know that 200, that is 200 modulus 6 will give you the result as 2, because you know 633s are 198, 633 is a 198, so 2 is the remainder, so you will get the answer as 2. So why we are doing the typecasting? We cannot do modulus operation on the floating point, so that's why we are typecasting into int, within this int, and then we are storing in the result. So that 2 needs to be pushed now. This will be popped, 6 is popped and 200 is popped. Now your stack will have only one value, that is nothing but the your stack will have only one value, that is nothing but the 2. So we'll update over here. So your answer of this now your newly updated stack will not have this value, it will have just 2 now. It will have just 2. Now I12 is done. Next it is I is equal to 13. What is I is equal to 13 now? I is equal to 13, we have 2, that is not equal to null character. So it is true. Your sim will be 2 now. Sim will be 2. So if it is sim is equal to 2, I am directly pushing onto the stack. I am directly pushing, because if is digit sim 2 we are checking, push sim minus 2. So directly I am pushing onto the stack. So it will not go to the switch. Next iteration I will be 14. So in that 14 I have power. Power is not equal to null character. So it is true. Now your sim will be having power. Sim will be having power. Now it will go to the switch. In the stack you have 2, 2. It will go to the switch of power symbol. So power is over here. Power is over here. Power is over here. So in the stack you had 2 and 2. So operand 2 is 2 and operand 1 is 2. Power of operand 1 comma 2, that is nothing but 2 comma 2. So 2 power 2 is nothing but 4. So that result will be pushed back to the stack. Now your final result of this is stack will be having 4 and the result is also 4. Now you got the result is equal to 4. So it will come out of the loop. So I will be getting incremented. I will be getting incremented. So you came to know it as when I is equal to 15, it is null. So you know that it is equal to postfix of I is nothing but postfix of 15 is null character, that is equal to this actually. So this will not work. It will come out of the for loop. It will come out of the for loop. So it is an end of switch and end of for, and then result will be stored over here. That is result is nothing but result is equal to pop. So result will be having 4, and then I've written a if statement over here. If top is equal to minus 1, if top is equal to minus 1, okay, if top is equal to minus 1 over here, print up the result, because your when top is you don't have anything, result is equal to pop, you're done. Now your top is equal to result, whatever the result, I'm going to display the final answer. Else invalid postpic expression. Why this particular condition is, for example, you had you popped this, after that also you had one more element on the stack, and it is not a proper postpic expression, so it is an invalid expression. For example, your result had only final result was 4, after that you had something like 5 again, so it is 5 and then you don't have any operator. Answer was 4 and then you pushed 5 and then you don't have any operator to perform that, then it is an invalid postfix expression. So else part is invalid postfix expression, and then again top is decremented to minus 1. So this is regarding the evaluate function. This is regarding the evaluate function. I hope it's clear with the function, how to convert how to evaluate the postfix expression. So regarding the main function as well as the solving the tower of an eye problem, we'll see in the second session of lab 5 program, and also the demonstration of these 5A and B, that is together we have done in one program itself, will show in the next session. So in the next session you'll be seeing the main as well as the tower of an eye function as well as the demonstration of this program in the code blocks. Thank you.